The following is an example of a continuous probability problem. It says, according to a recent AP poll, approximately 40% of American adults with a standard deviation of 0.01265 indicate they use the internet to get news and information about political candidates. What is the probability in a sample of 1,500 American adults that more than 42% of them say they use the internet to get this information? This problem represents a continuous random variable because this percentage that we're looking at can take any value on a range. It could be 40.5, it could be 80.6, it could be 52.27. The difference between a continuous and a discrete random variable is discrete has to be a countable number. And since this is any number, we're actually going to use a normal distribution to solve the problem. So the first thing we want to do is identify our random variable. We are interested in the percentage of people who use the internet as their primary news source, so we're going to identify that as random variable x. Then we're going to identify our normal distribution. The normal distribution is what we use to solve continuous random variable problems. So this really is a review of what we did in Chapter 2. So since our original poll showed 40% of American adults using the internet, that's going to become our mean, and we were told our standard deviation was 0.01265. Now, we are interested in what percentage of people use the internet to get this information, and we're interested in what's the probability that more than 42% of them said that they got this information. So here's our problem. I want to know the probability that a random variable is greater than 0.42. Then if you can recall from our Chapter 2 and our normal probability problems, we draw a picture with our mean marked and our standard deviation, the area under the curve that we're interested in is shaded. I want greater than 0.42, so that's represented here. Then we need to find our z-score. If you recall, the z-score formula is observation minus mean over standard deviation. So here's that information plugged in, and we end up with a z-score of 1.58. Now that we have our z-score calculated, we can find the probability. If you recall, we find the probability by looking up our z-score in our table. So we have a z-score of 1.58. So I'm going to, in my table A, I'm going to scroll down to find the 1.5. And over here, across the top, I'm interested in the hundreds place, which is 0.08. So I'm going to go down this column and over on the 0.5 until I come to the one that matches both. Okay, now since we shaded above, I want the probability greater than 0.42. This 0.9429 represents the probability below. So to find my answer, I need to take 1 minus 0.9429. And I should get 0.0571. Okay, and that would be the answer that I'm looking for. This is the probability that in a sample of 1,500 American adults, that 42% of them use the internet as their primary news source. Now, before you end this example, I do want you to start getting in the habit of using your calculator to find this probability. So if you grab your calculator for a second, I want to go over a couple things with you. Under your distribution menu, which is second variable, is where you'll find your commands that we're going to use to find the area under the curve. If you recall from Chapter 2, we're going to use normal CDF and the inverse norm functions. And I do want you to get in the habit of using your calculator because I think it'll make it a lot faster in solving these problems. So in order to find the area under the curve, we're going to use normal CDF. So if you hit number 2, for some of you it takes you to a screen that looks like this. For others of you it takes you to just a parenthesis, and we'll talk about what to do with that in a second. Basically your lower and your upper, that's the boundaries of your shaded region in the picture that you drew. So if you recall from our picture, our lower bound shaded region was 0.42. Now in this case our upper bound shaded region is going to be a really big number. I want the number to be big enough so that it's over 3 standard deviations away, so I'm not adding any more area underneath the curve. Then we're going to tell the calculator our mean and our standard deviation, which is 0.01265. And then if we hit paste, it's going to show us our whole big long command. And so if you look here in this menu, those of you who just came up with normal CDF in a parenthesis, this is what I want you to fill in. It stands for, again, your lower bound region of your shaded region or your shaded area, upper bound region in your shaded area, your mean, and your standard deviation. So if we go ahead and hit enter, it'll calculate the area under the curve with these boundaries, and that value should be the same as the one we got from the table A.